Welcome back to the Automation Podcast. My name is Shawn, and this week on the show, I meet up with Thiago Alves to learn all about OpenPLC. Thiago, thank you for coming on the Automation Podcast. I really look forward to learning all about OpenPLC. But before we go into that, could you please introduce people to yourself and your background, and then tell us the story about how OpenPLC got started?
Sure. My pleasure to be here. Thank you for inviting me, Shawn. That was really nice, and I'm really excited to share some things about OpenPLC with all of you. So a little bit about me. I'm Thiago Alves. I'm from Brazil, so that's why I have a little accent here. And my background is on electrical engineering. So I graduated a couple of years ago, well, several years ago, in electrical engineering in Brazil. And then I went to work for on the automation company. It was a company called Aetra, and they were building cars. They're still there, and their main client is Fiat. And when I was there, I was like a little intern there, my first job. I was introduced to PLCs, right? And when I was working there on this little intern job, I learned how PLCs are so expensive, and my little young mind thought like, this shouldn't be that expensive. I can fix this. I can work with this with using like little electronics projects and microcontrollers and relays. And that's how the idea about OpenPLC was born, right? So that's just a long story short. I continued improving on that intern and wanted to study more about it and study abroad. So I wrote a paper about OpenPLC prototype thing that I was building, and that got attention from a couple of scholars, and one of them invited me to do a PhD with him. And that's when I moved to US in 2015. And that's actually when the project, started moving forward and progressing pretty quick. But yeah, this is my little background. I started on electrical engineering in Brazil, moved to computer engineering and cybersecurity in 2015 on my master's and PhD, and focused entirely on building a platform that would allow people to do research and explore the PLC and automation world for free. And that's OpenPLC, right? And after that, I went to work a couple of years for Deloitte. And after Deloitte, I finally moved out a little bit from the automation world. I'm now head of security research for a company called Mosel. And I do more like endpoint protection. It's not related to automation or PLCs or anything like that. I still miss that. And I still maintain and support and improve OpenPLC on my free time, so that I don't leave my passion for automation to die, right? But this is my story, really condensed.
Well, I tell you what, I mean, one of the hottest things in automation today is security, cybersecurity.
Mhm.
So what you're learning in your current job, we all have multi-talented people and we can do multiple things. I myself just don't focus on automation. I have other passions in my life. And it's great because now you're in a position where, these are very important. These both topics are very important. I think back to the TV series 24, and there was a season where they had the CIP device, and it was taking down plants and power stations and all this. And I just laughed because it was totally, back then it was like totally fictitious what they were doing. But in some ways, it kind of tells us that, hey, we need to be smart about how we connect the rest of the world to, our
Yes.
devices, right? But when I think Open PLC, I'm thinking this is a great way for people to learn,
Mhm.
to learn PLCs. And so tell us a little bit. We got the website up here. Tell us a little bit about what they'll find when they come to the website and what the project entails at this moment.
before we get to that, I have a special announcement. I've just released my very first book. It's an ebook and it's entitled Logic's Book of Knowledge. What I did is I combined all my Control Logix articles from the last 10 years into an ebook. I updated them, I added new pictures, and I made it all available for just $9.99. So if you appreciate what I'm doing, if you want to support the show and the channel and the blog, then please check out my brand new ebook, Logic's Book of Knowledge, which you can get over at theautomationblog.com/BOK1.
Right, sure. Let me just get a little segue on the security here for a moment, because that was the entire topic of my PhD. I think we can have an entire podcast about this,
Sure.
but just I think this is really important nowadays, and people don't take it seriously, right? At some companies, when I was working at Deloitte, it's like a consulting company, right? So people will go to Deloitte to ask questions and pay a large amount of money so that they have experts to answer their questions properly. And that's exactly what I was doing there. And I was just amazed to see like large corporations. I can't mention names here, but like really large corporations with a bad mindset about OT security, right? And just thinking, oh, let's keep those PLCs isolated and we're good. But that's not exactly everything you can do, right? PLCs, unfortunately, because they are, I see PLCs as an eternal upgrade, right? They were invented in 1970s. And since then, they were just building on top of that original design. And that's why they're so insecure, because they were created to be insecure by design. But back then, there was no internet. There was no nothing you could really worry about connectivity. But then PLCs started to add on connectivity, not only on serial networks, the old-fashioned, but now on Ethernet, and some models even Wi-Fi. And then problems starts to arise because they use protocols that are not meant to run on those global networks, right? And take Modbus, for example. There's no authentication, nothing in there. And then with this, people start getting creative and creating cyber attacks for plants. A couple of years back, the world saw the Stuxnet attack, and that was a disaster happened in Iran when some government agencies created this malware that attacked a nuclear facility plant that was potentially creating a nuclear bomb. So with that worm, they just infected the plant and they destroyed the plant, right? And that was a silent attack. So today, PLCs, like the vulnerabilities on PLCs, is, for researchers, we see this as cyber warfare. This is a weapon. People can cause real damage by attacking and disrupting a PLC or anything connected to the PLC, right? So yeah, that was my little 5-minute on security for PLCs, but just to bring awareness. Now, OpenPLC was born with that idea in mind, right? When I was invited to start my PhD, the problem there was that people were researching about PLCs, but there were no easy means to get into the PLC world. Everything is closed source. Everything is like a black box. You buy it, you don't know how it works, and there was a lot of reverse engineering going on. And then I had this project about OpenPLC going on, but it was really a prototype, right? It was very simple. Basically, it was a design based on top of Arduino boards and relays and some protection schemes. And it run on a very crude ladder logic editor based on LD Micro. Some people might have heard about LD Micro. But then when I started my PhD, I realized that OpenPLC could be a tool to leverage research for PLCs. So we bought a bunch of different PLCs, and I started doing some reverse engineering to understand how they work. We got the IEC standard, right? And that's how all PLCs should work. And based on that and some other open source tools and software, I started putting together what's now OpenPLC. So here, what you see here is OpenPLC website. If you're trying to learn more about PLCs, or if you're trying to, research more about how PLCs work from inside out, or even if you're interested in cybersecurity, OpenPLC is the tool for you, right? The entire source code is available, so you can check it out. The project is composed of two components. What you see here on the screen is the editor that it allows you to create your PLC programs. This editor is based on Bermis IDE. It's a powerful IDE created a couple years ago as well that is fully compliant with the IEC standard. So that means that, you know, the IEC 61 131.3 standard that talks about how PLCs should be programmed, it's all there. So if you've used any other editor that is compatible with that standard, you should feel familiar with all the same blocks, the same structure, the same language, the same syntax, right? And that's why it's interesting to use OpenPLC to learn, because even if you're not using OpenPLC in your job, if you're not programming any PLC with OpenPLC, everything you learn here will be 100% used on, you know, Siemens TIA Portal or Rockwell Studio 5000, you know, all the other editors that are compliant with that same standard.
Now,
Right?
I want to just, for the audio audience, I just want to just for a moment describe what the editor looks like. It's your standard IDE where you have a column of items on the left, you have a column of items on the right, you have like a message window at the bottom, and in the middle of the screen is where you do all your work, whether you're, you know, creating function blocks or ladder logic or whatever. Now, my question for you is, number one, is this OpenPLC editor free? I see that it supports Windows, Mac, and Linux. Is it free or is there a charge for it?
It's absolutely free and open source. So, for example, if I just open a new tab here, for some reason the keyboard is not working. There you go. And go to my GitHub page, and you will see all the projects that I have there. And as I mentioned, OpenPLC has two components, the editor and the runtime. Both of them are free, open sourced on GPL v3 license, so you don't have to pay a dime to use this. It's absolutely free on schools, work, you know, anything you want to do with this. So this is the OpenPLC editor, and you can find here the entire source code for it, right? You can also see the development branches and see what's going on, what are the latest and greatest in terms of the editor. Same thing goes for the runtime, and I will explain about the runtime in a minute, but this is the third version of the runtime. The runtime was the thing that was born first, right? Something that can go on a device and run a PLC program, right? So this is the first thing I built, and it's now in the third version. Same thing, you can find the entire source code here, you can browse about, you know, different branches and development, and there are instructions on how to install, how to use this, and it's all good and it's all free. So if you go back to the OpenPLC website, when you're directed here to download a Windows, Mac, or Linux version, this is for the editor, okay? So I'm on Mac OS, for example. You click on Mac OS, and once you're there, it will give you, oh, it's a little slow today, yeah. It will give you a little option here to donate if you want. It's not mandatory to donate, but this is a great way to support the project. We use this money to pay for developers, to improve and fix bugs and keep the project going, right? So if you are interested, if you're excited about the idea, this is a great way to support the project. If you don't want to donate now, you can just click on just download, and it will start downloading the file right away.
Now let's talk about the features of the editor just briefly. IEC 61131-3. So which of the languages are supported? I'm assuming ladder logic, but why don't you tell me which languages are supported?
So let's start the editor and start taking a look at this. I know that there are some audio audience here as well, but let me just open up here from the applications. There we go. OpenPLC editor. And here it is. So yes, it does support all the 5 languages: ladder logic, structured text, instruction list, sequential function chart, and function block diagram. All the 5 languages are supported on the editor. And you can use multiple languages on the same project, right? So for example, I just opened the editor here. I can start creating a new project somewhere. Let me just go to File, New. And projects on OpenPLC editor are folders. They're not a single file. So I can go here, for example, on Documents, and I have a place here on Code where I keep, I will just create a new folder here on Code and say PLC Programs. And then I can create a new folder for my demo program here. And that's a blank folder. That's what I select when I create a new project. So here I get a screen where I have to type, basic info about my project, a demo program. And then this is a program, right? I can't escape from this. And here on the language, as you were asking, I have the ability to choose from one of the 5 languages. Ladder logic is the most common. I'll just pick this one just for this little
Now, I want to
example.
stop you there. For
Mhm.
those who don't know, you see the POU there, and if you're using Allen Bradley or Siemens, or you typically won't see that nomenclature, but that is actually the POU is actually what's in the standard. So while
Mhm.
you don't see, you see programs, tasks, and routines inside of a Studio 5000, inside of TA Portal, you got, OBs and FBs and FCs and data blocks and all that. But where that POU, Program Organizational Unit or Organization Unit, that is actually right out of the IEC standard. And that when he created that, just for the audio audience, he had to choose the language for that. So every POU can only have one language. So can you create multiple POUs in your project, in one project?
Yes, yes, you can.
Okay,
So
good,
here on
good.
this gray add button here, for example, you can create another POU, right? Program Organization Unit. This is how the standard defines, different, in simple terms, different segments of your project, of your program. If you say in simple words, your program is a group of many items, right? Which could be a little program here and another program running on the same project, right? Or functions, sub-functions, or function blocks, or things like that. So all of those things are POUs, and you can manage them all here on this left menu here. Okay, on the left
So your
part
project,
of the
what
screen.
we call a project tree, I think most who have used the
Mhm.
RS Logics would be or a controller organizer or a project tree. But yeah, you
Yes.
definitely get some do you get tags in there? Do you get the choice? It looks like you have 2 items under unnamed.
Yes, you can create your tags. It's mandatory actually for you to create your tags here. Before we start populating this, let me
Mhm.
just show you the resources as well. This is also part of the standard, and the resources tells you how you're going to run your POUs, right? Your programs. So when you create a new project, it's already populated here for you. A task running cyclically every 20 milliseconds and an instance that is associated with that task running your only one program. If you go and want to create another program here, for example, and call it demo2,
Mhm.
also in ladder logic or whatever, um, you now have 2 programs here, and on your resources you would have to create another instance, for example, and
Mhm.
another task, and then say, hey, this new instance will run my demo2. So you can have 2 programs running at the same time at different intervals. For example, this
Mhm.
one will run at 100 milliseconds. So yeah, it's
Yeah.
multitasking even on an Arduino Uno board. So it's you have all the sophistication of IC standard on 2 kilobytes of RAM, which is
Well,
almost
that's
incredible.
I definitely want to get to the runtime destinations for these programs, but this part here reminds me a lot of CodeSys, and
Mhm.
I think when I'm using Studio 5000 or TA Portal, I'm not thinking about this part so much. because it kind of does this in the background automatically. But in CodeSys, I found that this is an important part of the configuration, and you just did it here, so it's very familiar from that respect. But can you put together a little program? And I know the audio audience, you can't see this, so we'll try to be verbally descriptive of what we're doing.
Yes. Let me just erase the demo program here because we're not using this now.
So we're going to have the original. Yep.
Yeah, just keeping the original here, and then we can go and do some more things here. But yeah, you mentioned CodeSys. I like to say, like, CodeSys is pretty much the vanilla standard. They do everything like the standard says, and it's pretty much a perfect implementation of it, right? I like to imagine this as like Android from a Google phone, because it's the vanilla Android. No one touched it. It's just plain Android. It works as it's intended. All the other variants, Samsung or any other vendors, they put their little touches here and there. It's not the vanilla Android anymore. It looks different. It feels different. So this is CodeSys, and in my view. And OpenPLC editor is pretty much like that. Obviously, with the resources we have at the moment, we can't be as sophisticated as CodeSys. They're like a multi-million-dollar company. But we try to get there as much as we can using open source tools, right? Yes. And that's the purpose. So I mentioned about tags. Yeah, that's how you build your program. So for example, if I want to blink an LED, right, just a simple blinky toggle an output on and off, I would have to put that output somewhere here. So I create a variable, and that variable or that tag is where that location will be activated with my output. Right, so I'll just call this blink out, for example, and this is a local variable, so it belongs to this program, and I can select the type for that tag, for that variable.
I was going to ask that. Okay.
Yeah, and you have all those types here. For those that can't see, it's like Boolean, integers, date, time, strings, and all of that, all the good stuff from the standard. I will just put it Boolean because it's a blinky output. And the location part is where the magic happens. Let me switch to the website for a minute.
Sure.
And then I will talk about this. So if you go to documentation here, this is where the good stuff is related to what we can learn about OpenPLC. And if you go to runtime, there's a topic here called physical addressing. And then it has like tables for all the hardware boards that are officially supported on OpenPLC. Okay, in OpenPLC, you divide this in two different groups: microcontroller-based boards and Linux-based boards. Right. The difference is because the runtime for Linux-based boards is much more sophisticated. Right, it has a web server that you can play with stuff. And you have different SCADA protocols you can add. It's much more sophisticated because the hardware supports a lot more. For the microcontroller-based boards, the runtime is what I call the micro runtime. It's just a small version of that Linux runtime that is suitable for microcontrollers. And for each one of these microcontrollers, you have all the standard outputs and inputs for that board. So if you know, for example, an Arduino Mega, or Arduino Nano, where is it? Yeah, Mega, for example. You have all those pins around the board and the pin numbers, and here's the location or the IEC location for each one of those pins. So they're already pre-mapped for you, right? So if you want to blink an output, if you just put, for example, QX 0.0, that is associated with Arduino Mega pin 14. If you're burning this program on an Arduino Mega, right?
What is the inputs? It's kind of small. I'm having a hard time seeing it. Are the inputs eyes?
Yes, inputs are eyes.
Okay.
Yes, I just increased the size a little bit. Yeah,
okay,
I forgot that.
Thank you. I didn't know if it was I or T, and the standard says I and Q. So
yeah,
Allen Bradley people are used to I and O, but the standard's I and Q.
Yeah. So this is exactly as the standard says. Q is for output, I is for input. I don't know why Q is for output, honestly. Probably in some European language that might be an output for some reason. But X is for a binary location, right? So you're talking about bits. So if you're talking about a variable that has a quantity, right, it's not a single bit, you will use words or doubles, right? So and you have letters, acronyms for those.
Yeah, this will be
So
very familiar to people who use Siemens, except for the digital, you don't have to put the X in there. So it's like I0.0,
mhm,
but with the percent sign in front. And that's a big thing that you won't see on the Rockwell. But if we do want to address an entire word, we will use like the IW, the percent IW or percent
mhm.
QW. So Siemens folks should be very familiar with that kind of nomenclature. Rockwell guys, that's just part of how Siemens does it and how the standard does it. But so this is good. So you really need to understand that, and of course the Mega is a very popular board. The Nano is a very popular board. So these are some of the most popular little boards out there. Actually, in the morning show, and of course we're filming this, so this won't go out for a few weeks. But if you go back to January 25th, when we were filming this on the morning show, I talked about a new guide to all these type of boards, including Raspberry Pis and others. So that's put out by Make Magazine or Make and DigiKey. So if you're interested in the hardware, there's a great guide out put by those two companies that kind of goes over them all. They're all really inexpensive.
Uh-huh. Yes. It's interesting. I mean, some people just approach me and say, hey, you're building software for an Arduino Mega board that costs like $10 or less, probably less. But there's no use for this in industry. And that's right. There's no use for an Arduino Mega in industry because, all the noise and, the electrical protection that you don't have on that board. But there is so much potential for this for people that are learning, at home or at school. They don't have to buy an expensive $500 PLC to learn how to program real PLCs. They can do this on their little mega boards using breadboards at home with LEDs and push buttons. And in fact, that's what I've done in the past when I was teaching at university. I just had the cybersecurity course, but since people had no idea about automation, half of the course was about how to program a PLC. And they all had those little Arduino Uno kits where they could, put together and have little traffic light signal program running and things like that. But yeah, that it's very useful for those things. But also, there are some other platforms, real serious platforms like P1AM from Productivity Open P1AM. These little guys are Arduino compatible and they're manufactured by FACTS. FACTS is, by the way, one of the OpenPLC sponsors. They help the project move forward, sponsoring OpenPLC and providing money for developers and all of that. So really appreciate their work and their sponsorship. But they have this device that is basically an Arduino Zero, right? A SAMD architecture, but it's a full-blown PLC, right? With modular inputs and outputs and all of that. It's pretty cool.
And
For
24
example,
volts instead of 5 volts, because I know a lot of these boards, correct me if I'm wrong, but most of the boards we're talking about, like the Mega, I think, isn't the voltage 5 volts?
yes, it's 24 volts protected, but it's a full-blown industrial PLC. You can put it anywhere you want. And it's certified, I think UL certified. I don't know about FCC, but this is what it looks like, right? It has an Arduino inside. Those pins, let me put the image bigger here. Bad quality image, but that suffices. This is their CPU module, and the left side you see those pins. These are exactly Arduino pins, so they're 5 volts and 3 volt compatible, right? You shouldn't put anything, 24 volts or any high current load here. But when you added modules to the right side, all these modules are industrial modules, 24 volts. And so this picture shows it pretty well. Like on the left side, you have all the Arduino shields, and on the right side, you have the industrial modules. And those modules are even compatible with their other lines of PLCs that are not Arduino compatible, right? So this is a Productivity Open. It's pretty cool. Here's a higher resolution of the module, right? And you can use it for anything. Because it's Arduino based, you can program this on Arduino. But because OpenPLC exists, you can also program it using IC language, right? When they created this thing, it was only possible to program this using Arduino. And then they approached us, and we started talking about possibilities to join forces. And then I added their device to the list. So this is pretty cool.
I'm going to ask you this. This is kind of a sidebar, but have you seen any Arduino shields that are 24-volt protected?
Yes,
Okay.
Rugged Circuits. I think Rugged Circuits is the one. They make Arduino compatible shields for that. Yeah, Rugged Arduino. That's what they do, right? It's not cheap, right? So if you add the price of the shield plus the Arduino board plus the Ethernet shield, because you want connectivity on that thing, it might add up a little bit. And then you're looking at a couple $100, and it's like, why not buy a Siemens instead? But their shields are pretty great. I've used them in the past on my research, and it works pretty great, right? So using OpenPLC, you can program an Arduino board, put a rugged circuit on top of it, and there you go, you have a PLC, right? It's the same thing.
Well, and that's important because look, you're going to have when you're learning, when you're educating people, right? You're going to have two sorts of people. You're going to have the people who want to do all software, right? In which case they're going to want to stay with C++, Python, whatever, right? But you're going to have those other group of people who want to do something that's going to be, usable in industry, right? They're going to want to learn something that they can actually go get a job doing, like in the field, like making things happen, like, robots and conveyors and manufacturing. And for those people, learning Python and C++ is not going to be much help. So they can take the same equipment, they can throw some inexpensive rugged shields on there, and they can control whatever they're working on at home and learn the IEC 61131-3 languages at the same time, which
Yes.
will make them invaluable in
Yeah.
in industry, because industry is always looking for more controls engineers, automation specialists. They're so hungry for that. And once you learn that, you can start doing HMIs, which is really easy and fun, and you go, just the sky's the limit. But
Yeah.
that's why I think starting with a $10 board, and maybe you just start doing some programming, and then maybe you get some shields, and start controlling things around your home or in your lab, or on your hobby. It's a great way for those who really are hands-on and want to make things move, make things happen, versus those who see themselves as a programmer sitting at a computer keyboard all day. Are you building apps and programs, or do you want to make things move? Do you want to interface with real motors and
Yeah.
things in the field and actually make things happen? So kind of two different worlds.
Yeah, absolutely. And I agree 100% with you. And that's one of the main motivations for OpenPLC, to lower the bar for people going into automation. Back then, when I was an intern at IETRA, if you want to buy a PLC, that was, especially in Brazil, that's super expensive. It was prohibitive for a student to have, right? So you only deal with that on your internship or some labs at school. And I just found that was such a problem. Why not have a cheaper platform, a way to learn more about this without having to go to school or be in your factory floor to learn about it. So OpenPLC is that. You can download it today and start learning today. There's nothing preventing you from doing that. My favorite board in this whole list is the ESP boards. I don't know if you've heard about those little guys. This thing, you can buy it for like $1. And it's very popular on the DIY world. Everybody uses ESP 8266 and their big brother, the ESP32. Both of them are compatible with OpenPLC. And the nice thing about this board is not only because it's super cheap, but also because it comes with Wi-Fi built in. So connectivity, Internet of Things, it's like so easy to make, right? It's so easy to have a board like that for little money and then program something for it to do and automate that and have an HMI for this with OpenPLC runtime. So OpenPLC runtime supports Modbus out of the box. You can burn your program there, and it will be talking Modbus automatically. So you can just go and get your favorite HMI software and start building your screens, and it will talk to your board just fine.
Yeah, I mean, this is definitely for educational purposes, getting started, home projects, just phenomenal. And it just teaches, lets people get their hands on with the basics. And you're going to probably, it's fun it's fun to build, a go-kart in your backyard, right? Is that going to be
Mhm.
your daily driver to go 45 minutes on the highway to your place of work where you're going to, no, probably not. You're going to
Mhm.
probably drive something that has a very long warranty and is safety meets all the safety standards and is from a major company. But that aside, and that's why most big companies will continue to probably purchase products from other
Mhm.
big companies because they need that dependability. But when you're talking about something that allows new users to get in and learn uh, automation, this is I think is just awesome. Now we've talked about the editor, we've seen a little bit for those listening, just to kind of paint a picture of you for you in the editor. You kind of and you've probably seen this with other developers. You build your tag table at the top of the screen above your canvas where you actually write your code. And why don't we go ahead and continue with that blink out, because we did kind of
Yeah.
segue over to talking about the destinations for the runtime, and that's great.
Mhm.
And I'm glad we did do that. But let's, if you don't mind, let's get back into
Yeah.
writing our blink program.
Yes, definitely. So here, the segue was because I need to put a location here. And as
Hmm.
we
Hmm.
saw on that table, you need to pick one of the possible pins. Depending on your board, QX0.0 will be related to one or the other pin, right? So for this example, I want to burn this on the ESP8266. So if I go back to my table here, QX0.0 is pin 0. So I would be blinking pin 0 on that board, okay, if I program this program there. I can put an initial value if I want, or any documentation about that tag or what it is for. But all I need is this for a blink example. On ladder logic, you need to add your power rails to your design. Let me just increase the zoom here so you can see it better. The
So
power
we have a
rails,
so we have a blank canvas, and in many programmers they come automatically, the power rails. But
yes,
here we're going to add them manually.
we have to add them manually. And what I like to do is just go ahead and put like 50, even if I'm not using them all, but put like a 50 pin power rail, right? So it comes right there.
Mhm.
And then I can add both sides, on the left side and the right side. And I do the same thing. I put 50 there. Uh, and then I align them to make sure that they are, to make sure that they are on the same place here, the same line
Mhm.
alignment, right? So that's pretty good. Those are my two power rails. Now I can start adding my blocks. For this blinky example, first thing I got to do is to add a contact, right? And the contact is the blinky out, right? I'll put this negated because you're going to see if I connect a contact with itself, it will just blink every cycle, right? So if I go here and add a coil um, to the same blinky out and connect them together like this, right? So it's a contact, blinky out, connected to a coil, blinky out. Then, if we just follow along mentally, the beginning of the program, blinky out is negated because it's 0. It will go through that contact and activate the blink out coil. Next cycle, blink out coil is true. It will go through that contact, negate it, be false, and then turn off the blink out again. And that cycle repeats forever. Now, this thing will blink at the speed of my PLC cycle. So if we go back to resources here, it's going to be 20 milliseconds. So it's blinking super fast. We can check this out on a simulation here. If I click on this running man here, it's going to start simulation. and it will just compile the entire project and have like a runtime built for your desktop, just so you can take a look at what the program looks like before you burn it on your board.
I'm glad you have a running man. I used to love that. That's what I used to call it in Factory Talk to You, the running man. Click on the running man. Now, I want to, just for the audio audience, just, to translate here, we have, if you're a Siemens guy, we have a normally closed contact. If you're a Rockwell guy, it's an examine if open, okay? That's our input, right? That's what we have blink out on. And that says, hey, if blink out is off, that I'm true, and then we go over to the output and we turn it on. And of course, as soon as the output's on, the input's not true anymore, so the output goes off. And at 20 milliseconds, or in any PLC, right, you would never see this change because it goes way too fast, right?
Yes.
The response time of our LEDs is typically, in our eyes, are not fast enough to see that. But here we're simulating it and we're seeing it because a lot of software does this. They'll still show it to you.
Yeah,
but
it's not. It's very true.
Yeah, it's very intermittent. It's not like a square wave. It's very intermittent.
Yeah,
like it's only catching it every so often, which is what you would expect, because at 20 milliseconds. Now,
internally it's turning at 20 milliseconds, but just the editor won't graphically show that back to you because it takes time to draw the screen. So you just see it turning sometimes on, sometimes off. But just like if you take a look at the variable, you can put out a graph here, and it's there, right? It's skipping some on the measurements, but that's it. The runtime internally is trying to keep that 20 milliseconds running the full blast, right? Now, this is running on my computer. It's just a simulation. It's not on the real hardware. And I'll just stop the simulation here. I cannot run this program that fast. It will not be useful for me. So what I can do to reduce this, add a delay here, I'll just add timers, right?
Perfect.
So if I add here
a block, okay.
Yeah, I go to add a block, and then the standard function blocks, I have all those standard blocks from the standard, and then I have here a timer on, right? And I'll just align my timer on with my rails here, and I connect my input here, just enable as well. So the enable pin, it won't allow me to add to the top. That's fine. I can live with this. Let me just go back.
I think it's awesome that you can stretch the timer instruction.
Yeah, I can stretch it and reduce it as much as I want, and make it, like, depending on how I want to
make it fatter.
Yeah, make it fatter, make it thinner, and that's depending on how I want to draw it. And I can just copy and paste this timer, and add another timer in front of it that is actually a timer off, right? Mm-hmm. And this will make my delay here for both the up cycle and the down cycle, right? So here I have it, and I'll just connect all the rungs here, and the output of my timer on goes to the input of my timer off, and the output of my timer off goes to my blink coil, right? Now all I have to do is to add my delay period. So this is a time period. Oops. Yep. I'll just put probably 500 milliseconds. That's good enough. And I'll connect this to my PT input for the timer on, and connect that to the PT input of the timer off as well.
Now those are constants. You're basically putting number boxes in with T-pound 500 MS, which for the Allen Bradley folks, that is how we do timers and other PLCs, how we do the preset time, or the PT, right? Mm-hmm. Which in Allen Bradley we call a PRE. But in any case, so those, you didn't actually create variables. Those are like constants, correct?
Yeah, I could create a variable here if I wanted and connect the variable instead, because I'm not planning to change.
Yeah, it's just quick. Yep.
Yeah, it's just adding a constant here on the program itself. I don't have to create a tag. If I create a tag here on the top for that time constant, the advantage is that I will be able to change that on the during runtime, right? So if you press a button and you add 100 milliseconds to the time constant, it will just make the timer slower and slower, and you change the frequency of the output, right? So if
Now, go ahead.
yeah, if I compile that again, you will be able to see the wave much better. You will see that it takes in consideration those timer on and off, and you will see a square wave, more correctly square wave this time.
Now, as our listeners know, I teach over at theautomationschool.com. And one of the things that kind of frustrates me is some PLCs do not support long time types. I saw in here that the counters, you did have counters that supported DINT and lint, which is great because not all PLCs support more than 32,000, which is kind of getting really old, long in the tooth, right?
Yeah, yeah.
But when it comes to your timers, so your counters support those data types. Do your timers support long time, or I mean, are we going to max out at 24 days, or?
Yes, the timers do support a long range. That actually, oh, let me close that instance because
Oh,
it's
we're
outdated.
still, yep, we're still running it. Oh, good.
Now it opens the new instance. Yeah, it depends on the platform that you're uploading this to. Honestly,
Oh, all right.
the runtime is going to use the C library for that platform, and the time constant is actually translated to libc time definition, right? What standard lib time.h defines as what time is. So some platforms that's a long, sometimes that's a long, sometimes that's an integer. So 32-bit, 64-bit or more. So really it depends on that platform.
Now, is there a way to choose, let's say how show me again how you chose the hardware in this project?
Yes, I will show it to you. Let me just stop.
Yeah, go ahead.
I had some other virtual machines running here just to show how OpenPLC would run on different operating systems. But this is just consuming my CPU so much that I can't show everything at the same time. So I'll just stop those virtual machines here in 1 second. But again, if you want to upload this to a hardware platform, basically you have two buttons here on the top. This orange down arrow is to generate a program for OpenPLC runtime. So this is for the Linux runtime, right? So you have to manually install the Linux runtime on your device. So it's a Raspberry Pi, it's a UniPi board, it's a new OpenPLC, it's all the supported, there are commercial PLCs and open source hardware boards that supports OpenPLC runtime. So once you install the runtime on that board essentially becomes an OpenPLC device, right? A generic OpenPLC device. And on the runtime, you can configure how that runtime interfaces with your physical hardware. You know, all the pins, you know, the protocols, the SCADA protocols, Ethernet, and all of that. But essentially, that is a generic OpenPLC device. So when you click on that button here, it will generate this program here that we just made for this generic OpenPLC device. It will create a little ST file, okay? This ST file is basically this program written in structured text, and you'll just grab that ST file and upload it to your device using the runtime. Okay, I have pictures of this just for the sake of time. Here on the documentation, you can find information about how to upload programs to OpenPLC runtime. So once you have OpenPLC runtime installed on your device, basically all you have to do is click on programs, and then you'll find a list of all the programs uploaded to that device, choose file, and then select and write some little information about that program and select the file that you just uploaded, right? And click on upload program. That will make, you know, the runtime accept that program and start running it. Okay, so this is how you upload a program to the OpenPLC device. Now, with microcontrollers, you cannot install the runtime on them because they're just microcontroller boards. They don't have any operating system. They don't have any interface. It's just a CPU there with some pins. This is where the Arduino button comes in handy. So when you click on that, this is a partnership we made with Arduino to bring the Arduino compiler to OpenPLC editor. So now basically what that means is that every copy of OpenPLC editor has a built-in Arduino compiler inside. So we can generate a PLC program for any Arduino compatible board, any board. So if you can program this board using Arduino IDE, you can also program this board using OpenPLC, same thing, right? So there are some pre-configured boards here in this list. So when you click on that Arduino button, you will see this upload to Arduino board dialog, and then you can select from one of those predefined boards. So there's Arduino Do, a lot of them, yes. Arduino Mega, Micro, Nano, Uno, Controlino. They added their board. Since it's open source, they just added the code and I accepted it. ESP32, ESP8266, and all of that. Right, so you just pick your board. If the board you have is not listed here, but it is compatible with Arduino, you can easily add this to the list. It's basically a text file that you just add some information about your board. Okay, you just say, hey, I want this thing listed. You put the name of the board and you put the platform it uses. So it's this board is based on Arduino Mega. Right, it's a slightly different layout, but it's an Arduino Mega. And then you create a C file just to map the pins according to what you want, right? It's very easy to add. There's a lot of information on the OpenPLC forums about how to add your own board here. But by default, it comes with all these PLC boards listed here. So for example, today I have my ESP8266 D1 Mini. You just select the COM port where this board is connected. And here you have the option to enable Modbus. You can have either Modbus serial, so you're gonna spit the Modbus communication on the serial port, and Arduino has by default 4 different serial ports. The first one is the default port, usually the one that is connected to the USB, and the other ones are usually other pins associated with them. Or you can enable Modbus TCP for the boards that support TCP in some fashion, right? So, for example, you can have Arduino Uno with the Ethernet shield. That is what you want to look for, Modbus TCP. And then you just select Ethernet here because you're on an Ethernet shield. This one, because it's an ESP8266, it supports Wi-Fi. It has built-in Wi-Fi. So I just selected Wi-Fi here. And because it's Wi-Fi, I just put out some network configuration information. You should be able to do those things.
IP address, etc.
Yeah. If you put this blank, if you don't provide any IP address information, it's going to use DHCP to automatically find an IP address for you. I like to set an IP address so that you always know your PLC is at that address, right? The only problem is that if that address is not available, you're going to have a conflict. But you know your network. Usually you'll have fixed IP addresses in a certain range and DHCP addresses in another range. Yeah. So I put a fixed IP address here, a DNS and gateway for my router, the SSID or the name for my network here, AlvesNet. Created this thing for a demo, and a password.
As long as it's not Skynet.
And once you click on upload, it's gonna compile your project, right? And use the Arduino compiler to generate an output for that particular board you selected, right? So now it's very small, probably can't read this, but it's saying generating binary file. It already generated all the other support files for that project you created, and now it's generating a binary file that is going to be uploaded to your board. It takes a while. My computer is just loaded with stuff, so it's going to take a little bit. But usually when you're not multitasking, yeah, it should take like a minute to just upload everything.
Yeah, no, I'm just thinking here that I've always avoided using the Arduinos because I didn't want to program in C++ or Python or anything, because my day job is PLCs, right? So to me, I'm just thinking, man, all those projects I didn't do, I can now do now because I'll be able to use IEC 61131-3 languages, and I will be able to program and control all this great stuff for my personal projects, and I think some of our audience may be thinking the same way too. They're like, wow,
Uh-huh.
this is great. This is really good. Glad you put it out. Now, as this is building, I want to ask you, is there anything we didn't get to that you wanted to talk about?
Um, I think connectivity. One of the greatest things about OpenPLC is that it makes it easy for you to, you know, create a project, upload a project. It's all there. It's just a click of a button for all the popular open source hardware. But connectivity is a nice thing, right? Obviously, this is an open source project, and initially I created this focus on security. So how can we improve security of PLC devices? The default branch of OpenPLC has no security built in. It's just a copy of regular PLCs. And that was made on purpose so that everybody is aware of what a PLC looks like. So there's nothing great about this Modbus implementation. It's just a regular Modbus implementation following the standard. There's no security on that, which means that you can attack an OpenPLC device just like any other. In fact, in 2018, I went to DEF CON. It's a famous hacker conference that happens in Vegas. And I went there to present some pretty neat PLC hacking techniques. And I had 3 PLCs on the table running the same project. And with the same attack, I was able to attack all 3 of them at the same time. Just because those protocols are like that. They have no security with it. And one of them was OpenPLC. So with the same attack, it would be able to take down OpenPLC and Schneider M221 and Rockwell Micrologic's, I think it was a 1400 series. So yeah, it's the same thing. You shouldn't expect anything more. But with the connectivity, it's nice because now you selected the Modbus TCP icon. You can go ahead and create a little HMI for that, just using Modbus, right? I don't know if you've heard about SCADA VR before.
Say it again.
SCADA VR.
SCADA VR?
Yeah, B as in Brazil.
Oh,
it's a
okay.
Brazilian,
No.
Yeah. it is a Brazilian software. I have Windows running here, and it has SCADA VR installed. But the nice thing about it is the free HMI suite. So you can just open it up and create your little HMI and connect to the ESP board you just programmed and see that link output. Yeah.
Talk about that a little bit more, because I think most of us here are thinking, I love this idea of having my PLC running on a Mega or Uno or one of these Arduinos, but the next thing that comes to our head is, well, now what do I do for HMI? You're saying there is a free HMI software package out there called SCADA BR for Brazil.
Yes.
Oh, great.
And it's easy to find and install. They have installers for pretty much every operating system as well. One of them is Windows. And so you can just grab this, I think it's a MSI package or .exe, and you just double click on that and it installs it for you. I think let me take down one of the virtual machines here so I can add, give some more space so I can show SCADA VR, but I wanted to show essentially what it looks like. Let me open up Safari here and open their website so you can take a look at what it looks like. SCADA VR. And it's basically a free and open source HMI suite. And again, you can download it for free and browse the source code if you want, make contributions, pretty much the same style as OpenPLC. At some point, I tried to kind of like join with them and offer their package on my website, but it got confusing. People didn't know what is one, what's the other, and they were asking, solutions for bugs on the OpenPLC forum. I was like, I don't support SCADA VR that way. Like, I don't write code for them. But and I'm sorry if this is in Portuguese, but you can use Google Translate to just translate the website. But here you just have this download button where you can download the latest 1.2 Community Edition for Windows.
So this is a deal breaker if it doesn't. Is there a download that has English language?
When you download this, the software is fully in English. It actually adapts to the language of your operating system. So you can change it. It has Portuguese. I think it has some other languages as well. And it's basically just downloading the software. Once you download it, you're good to go.
It knows what
Right.
version of Windows it has, and it just sets it to the current setting of Windows.
Yes,
If
yes.
Windows is set
And
for English, it goes to English. That's great.
yes. And it has it is a web-based HMI builder. So basically, once you install this, it requires Java for you to have prior. So you just go to Java website and download Java and Tomcat. Um, but the installer will install Tomcat for you automatically. You just have to have Java previously installed. It's pretty neat because with that, you can, it's a full-blown HMI suite, right? You can add your devices using different protocols. They support DNP3, Modbus, and BACnet, and some variety of other protocols. And then once you add your devices, you can go and start building your screens. And you can add anything you want. You can add LED lights, you can add text, you can add pictures, background images, anything you want. And then with those screens, you can distribute just the link to those screens, right? The URL, and people will just load them and see them on their devices, iPads, iPhones, and anything you want. It's pretty cool. It's pretty complete. It keeps a historic of your data as well, so you can see graphs over time, how those, each one of those tags behaved. You can do scripts and manipulate that data and do something when there's an alarm situation or something like that. It's pretty complete. I really like SCADA, and it's a
So
shame that
it's
my window is frozen, but yeah.
so it's not just an HMI, but it turns your computer into an HMI service, so you can actually view the screens on your phone.
Yes, yes. It's a
Wow, that's
web-based
cool.
service. Yes, it's pretty cool, and it's because it supports Modbus. I like to show them together with OpenPLC, so you can program your board and open up SCADA and see it, them talking. Right, create a little screen, and it's pretty cool.
That's awesome. Well, I'm glad you mentioned that here at the end of the show because, I think that's the where people go next. It's like, well, what do I do for? And then there's our other HMIs out there that are free, but
Uh-huh.
kind of like if you're working this at home or trying to work with a youngster, getting them excited about, automation and controls, the next step would be HMI. And so that sounds like a great option, SCADA
Yeah.
VR. So definitely we'll have to take a look at that too. But we're running towards the end of the show. I just wanted to ask you if there's anything else that we hadn't covered yet that you wanted to get out there.
No, it's good. I think there's a lot more to OpenPLC than what we discussed, but this is to get started about it, right? What it is, what it looks like, and how to use this. I do have a YouTube channel with some tutorials about OpenPLC. You can just go to youtube.com/@OpenPLC, and you will find my videos there. And in those videos, you'll be able to see some more tutorials and contents about how to work with OpenPLC in general. There's even a video about connectivity and SCADA, using SCADA VR to show some values on an Arduino board. So it's pretty cool.
That's
There
awesome.
is a place you can go to find content. Yeah.
You have a great website that has a lot of documentation. You have a YouTube channel which you've just a lot of these you've recently added out there, so they're current and they're recent and talking about the current boards that are on the marketplace. So I really appreciate your coming on the show and telling us all about OpenPLC. If somebody starts using this and they're like, wow, Thiago has done a phenomenal job, and I really want to thank him for all his hard work. Can you show us again on your website where they could throw you a donation to help fund maybe future enhancements and upgrades?
Definitely. Yeah. Thank you for mentioning that. That's a way to have a project moving forward. So the easiest way to support the project is going to download, and when you're there to download the editor, pick your version, Windows, Mac OS, or Linux. And when you're right there, you can select one of these buttons to donate. So for example, put $25 and then click on contribute and download. It's gonna start downloading the editor here, and you will be directed to a Stripe checkout. So It's not on the OpenPLC website. It's directly with Stripe. So
Extremely,
just for people,
secure,
yeah,
think
secure and
secure.
yeah, you can use Apple Pay or just add your information here and click on donate. But the other option here as well is sponsoring. So we do have some sponsors here, FreeWave and Facts, as I mentioned previously. But if you want to sponsor it, you can go to our Patreon website. There are some tiers you can find to sponsor the project. There are different tiers with different takeaways from that, right? So some things you will get. So for the basic enthusiast tiers, like $3 per month and $5 per month, you'll just get general support on the forum and just show your love for the OpenPLC, right? And these are recurring charges, those $3 or $5 every month. Once you go to an OpenPLC friend tier, you get some more items to the list. Like $25 per month will give you access to a private forum category. $200 a month will give you access to a private tutoring session with me, and then your name or your company name listed on the software. Or $500 per month, that's the friend gold. This will give you exclusive access to beta versions of OpenPLC, and also the ability to add compatibility for your own hardware. So that's, for example, what FreeWave and Facts are doing. They have their hardware supported on OpenPLC because they are gold sponsors, and we wrote software to have their hardware supported on the runtime, right? So these are the tiers. You pick the one that fits for you, and that's a great way to support the project continuously, right? So every month you will have a way to contribute and improve the project.
Yeah, and I want to. I know we got a lot of vendors, so we got mostly users out there in the field using this stuff, listening. But we also have a lot of vendors because we have so many vendors on the show. Well, I know we have a lot of vendors who listen to the show, and I want to, just consider supporting this project and connecting your products with this product, because this is, I mean, what better way to get the younger generation involved in automation than to have something that's totally open source, right? That's and again, you're not going to put this in a facility and try to run your multi-billion-dollar plant with this. This is designed today to be completely open source, so they can get in there, they can tear it apart if they want to, and then put it back together, but also allow them to do projects and not have to worry about, like, when I remember when I was going to school for electronics, going to college, I don't know how many circuit boards and transistors and resistors and caps we blew up. But that's all part of learning, right? So
Yes,
you don't worry so much about short circuits and overloads and blowing things up when it's, we're talking a $10 pot, right? So
yes.
I just want to encourage any vendors that are listening. And I can't wait to try this myself. But Thiago, I really want to thank you for coming on the Automation Podcast and spending all that time with us to tell us all about OpenPLC. I'm really excited to find some time to get my hands on it myself. And with that, I just want to thank you again for taking time out of your busy schedule to come on this show.
Thank you so much, Shawn. It was a pleasure. I really appreciate you accepting me here and showing a little bit about OpenPLC to all your followers. I really appreciate that. I think it's gonna help the project move forward and spread the word. It's free. It's for everyone, and I think I just wanted that to be a contribution to the world. It makes me really proud. Just the last thing I wanted to mention, like during COVID time, 2019, 2020, I was contacted by multiple people that were building, what is the name for this? The air breather equipment using OpenPLC, right? And that was helping save lives in a very low cost. So they did. There was a university in India that actually had a prototype running and helping hospitals and people that are suffering the lack of equipment. And I was really proud of this, that the software I built for free is now being used to help people overcome disease. So this is just amazing. And OpenPLC is for everyone to use, and whatever you want to use, right? It's free of charge. It's open source. You can modify it. You can adapt it. You can change it the way you want, the way you like. And with this, I thank you so much for being able to show all that to the world.
Well, I hope you enjoyed that episode. I want to thank Thiago for taking time out of his busy schedule to connect with me all the way from Brazil to teach us all about OpenPLC and how it can be used with inexpensive Arduino and Raspberry Pi and other single board devices to let people learn how to use PLCs based on the IEC 61131-3 standard. So with that said, if you did enjoy this episode, please consider giving us a like and a sub. And if you're listening to the audio only edition, please consider giving us a 5-star review. It really helps us grow that audio audience. Now you will also be able to follow me at automation.locals.com and find all of my training courses at theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.